So today we're going to be reviewing first something that we covered last unit, which is graphing linear inequalities. It was something we kind of tossed in at the end after we'd gotten done graphing linear equations, which was graph a line, and then we were done. So we squeezed in this information right here. In fact, I think I pulled this directly from that set of notes. I forget which day it was. And it's basically a summary of all that information where we need the y-intercept, we need the slope, we're going to graph those, and then based upon the inequality sign, we're going to determine what type of line we had, or what type of line we'll need, as well as which side of that line we're going to be shading. So the first half of our notes today is actually review. So a couple things here just to pick them out. We're going to need the y-intercept. We're going to need the slope. We're going to need to know the type of line, and we're going to need to know where to shade. Come up with those 4 pieces of information. You have everything you need to graph a linear inequality. And of course, that table there is something that you would be provided as well on, say, like a test. I'm more interested in how, or in whether or not you can use it, less so and whether or not you can memorize it. So if I need to bring that back later, just let me know. But just note that this is something we covered in an earlier lesson in the last unit. So we'll just jump right into it. First example here of our review, linear inequality. Why do I particularly like this one already? I hear someone typing. Yes, awesome. Thank you. Awesome. I assumed it was just taking a moment to type out. So Miranda and Marissa both said it's in slope intercept form, which is perfect because it already means I can just straight away start pulling every step of information I'll need. So I'm not going to focus on the graph just yet. I am going to start pulling out that information. For those of you who are not quite sure what they mean by slope intercept form, really it's that y equals mx plus b format. And it's a dead giveaway when the y is already by itself. And that tells you you can start pulling the slope, the y-intercept, and all that straight away. So I'm actually going to go ahead and list them like I've done in the past in the order that I'm going to use them, starting with the y-intercept, which in this case would be the b. And in that spot here, it's going to be the -3. After we use the y-intercept here in just a moment, we're also going to need the slope, which is the m in slope-intercept form. And for this one, it is 1/2. Just remember, if it doesn't look like a fraction, ideally you'd like it to look like a fraction. So if it had been, say, just 2, we would have written that as 2/1. Just a quick conversion there. And then the other 2 things we need, because of that inequality sign, has to do specifically with the type of inequality sign we have. So if we were to look up here at this table, we're looking at a greater than symbol. So it tells me 2 things. It tells me that we're going to use a dashed line. And once we get that line in there, we're also going to shade above it. So just for the sake of my notes, I'm going to jot that down here real quick. So we're going to use a dashed line. And we're going to shade above. So those are the 4 things I need to know to graph this linear inequality successfully. And I'm going to get fancy real quick just so it doesn't blur together. Good. So jumping to my coordinate plane, starting with the y-intercept, we're going to find the y-intercept at -3, and that's going to be our first point. From there, my slope is going to help me find some additional points. So again, thinking of slope as rise over run, I'm going to, from the y-intercept, travel up 1, So rise 1 and run 1, 2 units. And I can do that a couple times to get a general sense of which direction it's heading. And if I wanted a few more points, I could do the exact opposite by going down 1 and left 2 to give me a total of 5 points. At least 5 points that I can see on clear grid marks in this little window we're peeking through. So that took care of my y-intercept. That took care of my slope. Now I look at the inequality sign. It told me that I need a dashed line. So I grab whatever straight edge is nearby. If you have a ruler, great, but really just the side of a folder or really anything that gives you a nice clean line to draw in there, that's perfectly fine. And then from there, also according to the inequality sign, we want to shade above the line we just graphed. And remember, it doesn't have to be super solid, just enough to where you and I both know which side of that line you're ultimately focused on. Because if you recall back to the last unit, that shaded region represents every single point that's considered a solution. So any point that lands in that shaded area, if you were to plug the X and Y coordinates into the inequality, it would work out to be a true statement, which is what we want. Also keep in mind, obviously, it doesn't stop at the edge. We're just looking. So there's more here, there's more up here, so on and so forth. Those are all the points that are considered solutions. Then we bring in our second example. Unfortunately, you'll notice it looks a little bit different than the previous one. And probably the first thing you'll notice is what? What's the problem with this next one? I saw Tira talking, but
it's not in slope.
Not in slope intercept form. So we have a little bit of work before we list the information. And that work is getting the y by itself. So I'm going to bring this one over here. And what I'm going to do is just to make sure I have enough room, got this kind of empty space up here. I'm going to go ahead and copy it down so I'm not crowding myself out here. So I'm going to go ahead and write the one that's hiding next to that x minus 2y greater than or equal to negative 2. Put my little guideline in here, make sure I'm not accidentally moving that inequality sign around. And then I go to work. I'm trying to get the y by itself. Excuse me. So first thing I'm looking at, got to start a little bit further away. And again, if I'm going too fast on some of these steps, some of this is things that we've done several times. If you need extra help during the work time, we can go through it more one-on-one. But at this point, I'm hoping that since most of you are ones who've been with me since the beginning and have been getting everything done, I'm going to go a little bit faster on getting that y by itself. So I'm going to subtract the 1x from both sides. So on the left, the 1x, take away 1x is gone, leaving me with negative 2y is greater than or equal to negative 1x minus 2. Remember, if they're not like terms, don't try to combine them. And I went ahead and led with the x term after the inequality sign, just because I'm trying to think slope-intercept form. Next thing on my list, still trying to get that y by itself. I'm going to divide every piece by a negative 2. Because on the left, negative 2 divided by negative 2 gives me a positive 1, which allows me to hide it, which makes y appear to be by itself. And then on the right, negative 1x divided by negative 2. Again, I like slopes that are fractions, so I'll simplify wherever possible. All that I can really simplify here, though, is that double negative is going to become a positive 1/2 x. And the -2 divided by -2 is going to give me a +1. Look good so far? Seeing the head nod, that's good. Almost. So it started off as a mistake I accidentally made, but then I realized, you know what, I'll leave it to see if anyone noticed. What did I do right here?
You didn't flip it.
Why, flip what? The inequality sign?
Yeah, because you divided it by a -2.
Yep, I divided everything on both sides by a negative. This inequality sign should have flipped and changed directions. So just as a reminder, I think I'm going to squeeze this in here. I'll write it up above here. So if you multiply or divide both sides of an inequality by a negative value, the inequality sign flips. Again, that's kind of been lingering with us ever since the end of Unit 1, when we're solving just regular one variable inequalities, get the variable by itself. There was always that chance that if we multiplied or divided both sides by a negative value, that sign would flip on us. Now, in the grand scheme of things, all of our information would have been correct except for the side that we shaded on. So some would argue that that is the exact perfect wrong answer. I'm just going to count off 1 point on a situation like that, because in the grand scheme of things, I'm more interested in the big picture. If that's all you're getting wrong, that is just a side conversation we have. I would say, hey, maybe give yourself a little sticky note like this, just as a reminder. That way, as you're working through those types of problems, you'll know, hey, I always forget when that sign flips. Let me keep a note nearby so I can keep track of, those problems. So again, won't apply every time, just when we're multiplying or dividing by a negative. But when it does happen, it does change what our graph ends up looking like. But now that it's in slope-intercept form, I can go ahead, I'm going to squeeze it off here on the side of the coordinate plane. I can list all the information I need to graph this linear inequality successfully. So again, writing them kind of in the order that I'm going to use them. First thing I need is my y-intercept. In this case, that's going to be the 1. Next thing I'll need is the slope. That's going to give me that rise over run. And in this one, it is 1/2. And then considering the inequality sign, this time being a less than or equal to symbol, it's going to tell me 2 things. First off, we're going to use a solid line. And then from that solid line, we're going to shade below it. So with that information now presented there for us, everything kind of just identified. Again, students usually ask, do I have to list all that every single time? Technically, no. If I was graphing this for myself, I would have just looked at the inequality sign, but that's because I've done, I kid you not, at least a couple thousand of these. I wish that was an exaggeration, but it's not. So y-intercept is going to start us at +1 on the y-axis. It's going to give us our first point. Our slope, has us traveling up or rising 1 unit before running to the right 2 units, for which I can do that a second time. And if I want a handful more or 2 more points, I can do the exact opposite. I can go down 1, left 2 to really clearly see where that line is traveling. Now, thanks to my inequality sign, this line is going to be a solid line. And with that line in there, again, according to the inequality sign, I need to include everything beneath it. That's it. So depending on the problem, I'll zoom out here a little bit. If we're lucky, it'll already be in slope-intercept form, in which case, pull those 4 key pieces of information out, slap them there on the coordinate plane, you're done. If by chance it's not in slope-intercept form, don't panic. Get that y by itself. Be mindful of the chance that the inequality sign may flip on you. But once it's in slope-intercept form, yet again, pull those 4 pieces of information, put them on your coordinate plane. So I will admit today is a little bit repetitive, but review has never hurt anybody. Now, before we introduce the new information, let me think here, see how I'm going to do this. Squeeze it on the screen. I don't even need to know the inequalities per se, so I'm going to put it right there. So now we can see the graphs that we've put together, and now we can see the next little bit of review, which is asking us whether or not a point is a solution. So it's asking it reminds us that all points in a shaded region are solutions of the given inequality. Actually, I'm going to underline in particular, because I think that's going to make it pop a little bit more. So all points in a shaded region are solutions of the given inequality. So it's asking us to refer up to our examples A and B here immediately above them, asking us to circle the points that are solutions for example A. So if I was looking here, first ordered pair, 0, 0, is it a solution? Yep, I'm seeing a head nod. So yep, so I would circle 0, 0. Then I go and find 2, -4. So again, remember, the one thing I notice students mix up is we get so used to graphing and we think rise over run because of slope. Sometimes we forget that when we transition back to ordered pairs, it's actually the x coordinate that comes first. So depending on what you're doing, rise over run, you go up and down first. Ordered pairs, you go left or right first. I saw some students get that a little flip-flopped on the last test. But 2, -4 is going to have us going right 2 units, down 4 units. Is that a solution? Tiara's shaking her head no. I'd agree. So I know it doesn't say exit out, but I'm going to slash through it. 3, 1, again, back to the origin. We're going to go right 3 units, up 1 unit. Lands us in the shaded region, so that one looks good. 0, -5, so we're not going to go left or right. We're just going to go down 5 units. Unfortunately, that takes us below the line of that first graph, so not a solution. -4, 3 has us going left 4 units, up 3 units, which is way in the shaded region, so that one would be one of the solutions. And then the last one there, 4, 0, has us going right 4 units, but does not have us traveling up or down. So it's close to the line, but it is still above it. So it's a solution as well. So of that list of 6 ordered pairs, 4 of them happen to land in the shaded region that we created. Now, that doesn't mean that those are the only solutions, because remember, any point, anywhere I land in this shaded region and beyond would be a solution. Just in the list we were provided, only 4 of them worked. So same process here. Real quick, I'm gonna actually pause for just a moment and let you take a look at the graph and take a look at the list of ordered pairs and come up with the ones that you think are considered solutions. So I'm gonna actually pause real quick, give you a chance to do that, and then we'll resume here in about 30 seconds. Okay. So it looks like to me, if I'm looking at this correctly, and hopefully you guys can fact check me as I go, I would say that 0, 0 is in there. 2, -4 is in there. 3, 1 is in there. 0, -5 is in there. -4, 3 is not. 4, 0 is. So Tira's nodding. So that's 2 people with the same answer. I'm assuming, unless someone argues with me, I'm hoping that that is correct. Some people think that I have a key nearby to just repeat this process. I don't. Every time I do these notes with you guys, I'm doing it completely from scratch every single time. So sometimes I make mistakes on problems that I've solved several times before, just because, who knows, pick the day. Something different every time.
You probably talk math when you're sleeping, huh? And
I try really hard not to, but I have woken myself up a few times in the middle of a math lesson. So
That's funny.
yeah. All right. So again, change the graph a little bit. Maybe some of you noticed this, but that was the same list of ordered pairs from one to the other. Changing the graph, changing the inequality obviously changes which of them land within the shaded region. And that doesn't, notice that the line also moved. So it wasn't just a complete flip-flop. Some of them actually worked for both of them. And that's going to happen. Sometimes you're going to have 2 inequalities and you're going to have points that work for both of them. And that kind of leads us into the new part for today. Because if you've been thinking about it so far, this very short unit, we've been dealing with 2 equations at a time. But so far, we've only been doing 1 inequality at a time. So we're going to expand now to include what are called systems of linear inequalities, to where we're not just dealing with 1 at a time anymore. We are dealing with 2 of them. So organization, I know I harp on it a lot, but organization is going to be tremendously important here, because if you think about it, we're going to have 4 pieces of information for each, which gives us a total of 8 pieces of information to keep track of. So what I usually suggest is start with one of the inequalities and see it all the way through until you finish it, till you get it on the graph. Because otherwise, if you're trying to juggle both of them at the same time, you're going to accidentally take some of the information from one inequality and some of the information from the other inequality, bring them together and make some sort of hybrid inequality without realizing it, and your graph's going to look a bit wonky. So organization is key here. So in total, because it's going to feel repetitive after a moment, because really it's the same thing we just did times 2. So I do apologize, but for that, I only gave us, I know some of you are writing, I'll bring it back real quick. I only gave us 4 problems to look at, and you'll notice that half of them are already in slope-intercept form. So I wasn't too mean. But I'll go ahead and pause again for just a moment. I know some of you are writing this down from scratch, so I want to give you a chance to jot some of these down here before we jump in. So I'll pause and give you about another 30 seconds or so. So hopefully you've had a chance, those of you writing this down freehand, had a chance to jot down at least enough here to get started. I know on that little pause there, Tiara did ask a good question as to whether we could use the methods we've used in the past. And then while answering it, I realized, man, this would have been a really good thing to record. So the answer to her, again, in case you guys have missed it or those who are watching the video maybe later, is we're actually less interested in where these 2 lines cross, Because if you think about it, an inequality is more than just a line, it's an entire shaded region. So systems of equations, we wanted to know where they intersected. Systems of inequalities, we want to know where the shaded, I don't know why I'm struggling with that word today, shaded regions overlap. So in other words, if you think about it, in the earlier examples, our lines cut our graphs in half into two pieces. Now, sometimes one side would be a little bit bigger than the other, just depending on where the line landed, but it cut the graph into two pieces. We're now going to be graphing two of them on the same coordinate plane, which means we're cutting our graph into four pieces. So our end goal ultimately is to figure out which of those four subregions we end up shading in so that it appeases both inequalities. And really that just comes all the way down to the details that we're going to identify through this process. So for the sake of space, I think I can squeeze it in here. I'm going to kind of cut my little blank space here in half. And that way I can kind of write down all four pieces of information for each, but all kind of in the same region here without hopefully getting them accidentally mixed together. And I'm going to start with the top inequality as if this was the only one I had and start listing the information because, spoiler alert, they're both already in slope-intercept form, so that saves me a ton of extra work. So the first one here, y-intercept is going to be the -3. The slope is going to be the 1/2. And then the inequality sign tells me that it's going to be a dashed line. And that with respect to that line, I will shade above it. So again, yes, there's a second inequality there, but I'm going to ignore it for now, at least until I am done with this top inequality. So I'm going to zoom out here a little bit, just enough to where I can see all that information. So I have a y-intercept at -3. So that's my first point. A slope of +1/2 will have me rising 1 unit and running 2 units to the right, which I can do a couple times, or go down 1, left 2 to see where that line's traveling. According to the inequality sign, this is a dashed line. And everything feels the same so far until right now. I'm going to make a minor suggestion. Because I already know that I'm going to have to shade again later for the second one, I'm going to suggest that when you go to shade for the first inequality, do it ever so lightly, because what we're ultimately interested in is the region we shade twice. So our final shaded part of the graph will be the darkest. So what I usually do personally is I just very, very faintly just kind of go whoop, just so I know which region I'm on. So in other words, think about it this way. I don't want to include this region down here. That is now excluded because I didn't shade there the first time. So I actually, for me personally, I go back and erase the extra stuff. That's not required. So long as your final region is the darkest, which you'll see here in just a moment, that's what makes me the happiest, because then it's clear. But me being a bit of a perfectionist at times, sometimes I go overboard. All right. So then we move on to the second one. So pause on the graph, come back up here to our inequality, and I'm going to run through kind of the same process for the second one here, already in slope-intercept form. So that means that the y-intercept, whoops, there we go. I know it's not much, but a slight color change I hope will help us differentiate between the two. So the y-intercept for this one is going to be a +2. the slope is going to be a -2, but for the sake of graphing, I'm going to put that -2 over 1 because thinking ahead to rise over run, I'd like it to have two parts to it. And then looking at the inequality symbol, which is a less than or equal to sign, that's going to give me a solid line. And with respect to that solid line, I will end up shading below. So with that listed, then I come back down to my coordinate plane. And I start putting it on there. So with the y-intercept at 2, I'm going to start at 2 on the y-axis. Notice also that by shading very, very lightly for the first one, still allows me to see the graph to get the second one on there. With a slope of -2 over +1, I'm going to go down 2 units and write 1 unit, which I can do a series of times. And if I wanted one more point, I could also go up to left 1, just to kind of really clearly see where it's occupying this coordinate plane. According to the inequality sign, we're going to use a solid line. And then also according to the inequality sign, we're going to shade below this second line. So that occupies this space right here. Now, right now it looks like a mess because I've got all these different colors here. But what I usually do is I go back and make it very clear which region is clearly the darkest. And the darkest should be the region where you shaded both times. So in this case, ours for this graph should be the region that is both above the dotted line or dashed line, but also below the solid line. So I usually take, if I'm doing it with a pencil and paper, I usually take my pencil and I go back and go a little bit darker in that region, just so it's clear. Now on my iPad here, I go a little bit more overboard, just so it looks pretty later. And there you have it. That is the region we're most interested in. Now, if you're a bit of a perfectionist like me and you like the aesthetics of these, I go one extra step. If I did a pencil and paper, I usually erase the little extra regions that I shaded just once. It's even easier on the iPad because I just tell it to get rid of the extra stuff there. And there you have it. So just to kind of summarize, why did I do this? What is so unique about this region right here? Any ideas? Thoughts, maybe? What's so unique about the points that land in this shaded region? If you don't know, that's okay too.
Is it because they're both shaded in that area, right?
So they are both shaded. So for both of our inequalities, we did shade here twice, which if you think about it, means that any point in this region, and it does continue out as well, just we had to cut it off because of the size of our graph, any point that you pick in this region not only works for the top inequality, it also works for the bottom inequality. So where this would be applied would be any kind of scenarios where you're dealing with what are called constraints. Situations where you know there are certain restrictions to what you're doing or what you're building. So what you would do is you would describe those restrictions or constraints using inequalities. You throw the inequalities on a graph. You can do 3, 4, 5 inequalities. It's really kind of cool because it basically makes an enclosed shape. And then what happens is all the data points that fall within that shaded region are all the possible outcomes. So hypothetically, instead of trying to figure out 1 or 2 outcomes, in theory, you could describe all the outcomes at once. which is a powerful tool because then it makes you much more efficient. You now have all the answers at your fingertips. So again, right now, because it's just pure math, we haven't actually tied it to a story problem. Not that we even will, because that's a little bit more advanced. It seems like we're just making pretty shapes and pretty colors and things like that. I promise you, though, there are actually some pretty astounding applications that if this is a route that you end up pursuing, you'll see these come again, in the future. Not in your high school class load, but potentially if you go to post-secondary education and take a few additional math classes, these could come up again. So just a heads up there. All right. So like I said, today is a little bit repetitive because it's pretty much the same thing over and over and over again. So what I may do, I'm going to do all of them. But if you get bored at any point, I will not feel disrespected if you have to cut out because you have another class or you have kids or what have you. I'm going to go through the whole thing for the sake of recording. But I apologize beforehand. It does get a little repetitive because it's just the same skills over and over again. But I'm going to move on to example B here. And right off the bat, I start to grumble a little bit because neither of these are in slope-intercept form. So I have some work to do. So I'm going to kind of try to use this blank space up here at the top. Actually, let me see here. Let me try to think ahead. We'll start with the first one and we'll see how much space we have left for the second one. So I'm going to start with the top one. Oops. 1x minus 2y greater than or equal to -2. And for the sake of consistency here, put my little guideline in there. So trying to get the slope-intercept form, old news, so I'm going to go a little bit faster through that process. So I'm trying to get the y by itself. Oh, having troubles with my tools today. Now subtract 1x from both sides. Which removes it from the left, leaving me with -2y is greater than or equal to -1x minus 2. And then I'm going to divide every piece by -2. On the left, -2 divided by -2 is +1, which allows me to hide it, leaving me with y by itself. For those of you who are thinking ahead, we did just divide by a negative sign or a negative value. So the inequality sign will change directions here and it will become a less than or equal to symbol. And then on the right, -1 divided by -2 is going to simplify down to a +1/2 x. And -2 divided by -2 is going to leave me with a +1. So this is the first inequality for which we can start identifying our information. So I'm going to have kind of a hodgepodge of work here, but bear with me. If I was doing this for myself, I would probably be doing it on one paper personally. So off to the right here, again, I'm going to color code mine anyway, so it should be easy to follow later. The first thing I want is the y-intercept, which in this case is a +1. Second thing I'll need is the slope, which is a +1/2. And then considering the inequality symbol, less than or equal to is going to tell me that it will be a solid line and that I will shade below it. So we have all the information we need to get this first inequality on our graph. So let me try to zoom out here a little bit so we can see everything all at once. So y-intercept at positive 1 has us at 1 on the y-axis for our first point. A slope of 1/2 has us traveling up 1 unit and to the right 2 units, or down 1 unit to the left 2 units. For this particular one, we will be using a solid line. And we will shade below it. Again, this is just our first one, so just enough to serve as a reminder so we know which side of that line we're really focused on. So give you guys a moment to jot that down if you're following along. And then I'm going to come over here, got a little space left over. I'm going to write down the bottom inequality, 3x minus 2y is greater than 2. And I'm going to work on getting that in slope-intercept form as well. So working to get that y by itself, I'm going to first subtract the 3x from both sides. Removes it from the left-hand side, leaving me with a negative 2y is greater than negative 3x plus 2. Then I'm going to go through and divide everything by negative 2. So on the left, negative 2 divided by negative 2 is a positive 1, which allows us to hide it, leaving y by itself. I did, again, divide by a negative value. So this sign also is going to flip and become a less than symbol. On the right, going through, cleaning up a little bit, one division at a time. Negative 3 doesn't divide nicely by negative 2, but it does simplify to a positive 3 over 2x. And then 2 divided by negative 2 is going to give me a negative 1. Please hold while I allow my OCD to take over. So from there, we now have our second one in slope-intercept form. We're ready to work with it, pull the information we need, see how that fits on our graph with the first one that we were dealing with. So let's see here. Our y-intercept is going to be a negative 1. My slope is going to be that positive 3 over 2. Finding something more interesting than just 1/2. And then our inequality sign, which is a less than symbol, is going to give us a dashed line. And we're going to shade below that dashed line. So still working with the same coordinate plane here. This one has us starting at negative 1 on the y-axis. So that'll be my first point. With a slope of 3 over 2, I'm going to be going up 3 units, to the right 2 units, which I can do 2 times. Or for at least one more point, I could also go down 3 units to the left 2 units to get a total of 4 points for this graph. Now, thanks to the inequality sign, this one is going to be a dashed line. Oh. And also with respect to that line, we are going to be shading below it. Now, technically that incorporates all this region here, but at the very end, we're really just mostly interested in where we shaded twice, which should hopefully be this region in here.
Part of me just wants to color in that triangle, but I didn't do it.
Right up here in this little region.
Yeah. No, well, yeah, and even in below that, the bigger triangle.
Oh, gotcha. Yeah, it's tempting, but if we clean it up a little bit here, take out some of the extra, that temptation, yeah, I know what you mean, because what we've done is we've cut our coordinate plane into four sections. This big one up here, this kind of narrow one down here, this little itty bitty one over here. But our final one is where we shaded twice. Now, hypothetically, had the inequality signs been different, going different directions, there is a possibility we could end up shading a region as tiny as this one and only that one. So there is that possibility. And sometimes students are really kind of uncomfortable because they think, uh-oh, I made a mistake. I only shaded just this small, tiny region. Let the signs guide you. They're going to tell you whether you're shading above or below each of those lines. And according to the information we jotted down, we were shading below the solid line, which if you notice, my region that I finally ended with is below it, but we're also shading below the dashed line, which is also below it there. So let those signs guide you, and having that information jotted down somewhere will kind of allow you to go back and double check if you made a mistake, or if it doesn't feel like it's the right graph, you can retrace your steps, because unless you've got a super memory, I forget what I do halfway through a problem if I didn't write it down. So err on the side of caution and write more of that information down for yourself. So far, nothing too crazy. They both seem relatively similar. And that's why I threw in 2 extra problems that kind of come at us from a slightly more unique perspective. So these are worth taking a quick look at as well.
Yeah, that bottom one is like, whoa, I don't know what I'm doing. But
you do know, it's just been a while since you've seen it. So that's why I threw these in here real quick, because sometimes the things that we haven't seen for a couple weeks, we forget that we've actually dealt with problems like it. So I'm going to go ahead and separate my work here yet again, because these are both technically in slope-intercept form. So that's convenient. Saved me a little bit of effort there. And I'm going to start with the one that's more in our comfort zone. I'm going to start with the one on the top, and it has a y-intercept of 2. Its slope, now watch that negative sign. Don't accidentally use it twice. What I usually do for myself is I like to attach it to the top value instead of let it keep floating next to the whole fraction, because a lot of the times it's very tempting to see it as both a -5 and a -3 at the same time. But as most of us know, a double negative would accidentally turn this slope positive, which I don't want to do. Then I take a look at the inequality sign here, which is a less than or equal to symbol. That one's going to give us a solid line, and we're going to shade below it. So this one has us starting at 2 on the y-axis. From there, with a steeper slope than what we've seen so far today, we're going to go down 5 units, to the right 3 units. And because of how steep it is, Those are really the only 2 points that we could fit comfortably on this coordinate plane. Had I given you a larger grid, we could put more on there, but that's okay. We're using a solid line. That one didn't feel clean. And with respect to that line, we are shading below it. So again, just enough to serve as a reminder, because I'm going to come back and clean that up later. Then we move on to the second. And this is the one Tier said, wait a second, I'm not quite sure if I remember this. But part of it might be because of the inequality sign. I don't think we graphed very many like this one. But if that had been an equal sign, maybe it would ring a bell. Because in our last test, we had one kind of similar to that, or at least on the review. Because anytime you have y equal to a number, that gives us a horizontal line. And this one is going to go through y at -3. So that statement there kind of takes care of both the slope and the y-intercept, because a horizontal line is very distinct. We do still need to consider the inequality sign, which is a less than symbol, which tells me that that line is going to be dashed and that we're going to shade below it. So horizontal line through y at -3. I always like to put a little point at -3 just to get my bearings before I go back and put in a horizontal line. Not to forget that it is in fact dashed. And then according to the inequality sign, we are looking at everything below it. So that means our final region has to be below both the lines that we graphed. So all the way beneath this horizontal line, but we can't go past that solid line that we graphed first.
So you can't go past that solid line right there?
Right, because if I were to include this region right here, I would be above the solid line. But up here, I said I would have to be below the solid line. So that region would not work for the first one, which is why it's not included. So even when you throw in kind of these unique lines, horizontal, and don't forget vertical would be similar. It'd be x is greater than or less than a value. You still can kind of follow that same guide, that same process. Excuse me. Now, the best for last. This last one's probably my favorite one, just because of how the graph looks at the very end. Unfortunately, neither of them are in slope-intercept form, so we do have a little bit of work cut out for us here at the beginning, but it shouldn't take us too terribly long. So I'm gonna start over here on the right side of the graph. I think I've got enough space for it. So the top one is gonna be the one I start with. I'm gonna put the ones in there that are hiding. So I'm gonna have 1x minus 1y is greater than -2. So again, our goal is to get that y by itself. So I'm going to first subtract the 1x from both sides. which leaves us with a negative 1y on the left is greater than negative 1x minus 2. Then I go through and divide every single piece, every term I should say, by negative 1. So I get y by itself. I did divide by negative, so the sign is going to become a less than symbol. But negative 1x divided by negative 1 is going to give me a positive 1x. Negative 2 divided by negative 1 is going to give me a positive 2. So far, so good. From that, I can then write that the y-intercept is going to be a positive 2. The slope is 1, but I'm going to write that as 1 over 1. It's going to give me that rise and run that I'm looking for. And then according to the inequality sign, which is a less than symbol, I'm going to be using a dashed line. And I'm going to shade below. So again, this was the top inequality we're given. So this one has me starting at positive 2 on the y-axis with a slope of 1 over 1. I'm going to go up 1, right 1. And these are always fun slopes because then we can get a ton of points by also going down 1, left 1. Double checking my inequality sign there, reminding myself that it is going to be a dashed line. And with respect to that dashed line, we're considering everything beneath it. So again, don't hesitate if I do anything weird. If you have a question, feel free to stop me. But so far we got the first one on there. Now we got to repeat that same process for the second. So the second inequality was 1x minus 1y is less than or equal to positive 3. Subtract 1x from both sides. That leaves me with negative 1y is less than or equal to negative 1x plus 3. And then I'm going to go through and I'm going to divide everything by that negative 1. So y is now by itself. I did divide by a negative, so I need to remember that that less than or equal to symbol is now going to flip and become a greater than or equal to symbol. Negative 1x divided by negative 1 is going to give me a positive 1x, and 3 divided by negative 1 is going to give me a negative 3. In slope-intercept form, we can start writing out that information we need. I'm going to do it here to the left. So my y-intercept is going to be a negative 3. My slope is going to be a positive 1, which I'm going to write as 1 over 1. And then the inequality symbol is going to tell me that I need a solid line and I need to shade above. Anyone notice anything about the line even before we start graphing it? This would be a throwback to
parallel, right?
How do you know it's parallel?
Well, I already graphed it. That's really how I.
Oh, okay, that's fair. I appreciate the honesty. Does anyone know if I hadn't asked you to graph them, does anyone know how we could have spotted their parallel beforehand?
Their slopes are the same.
Their slopes are identically the same, perfectly the same. Now, I seem to recall earlier, so last Thursday, when we solved systems of equations by graphing, I recall that parallel lines gave us no solution. And sometimes students want to stop and say, oh, this is hopeless, there's no solution here. But you got to remember, we are less interested in where the lines intersect, and we're more interested in where the shaded regions overlap. So let's just see what happens here. Some of you already probably already worked ahead, and that's because I'm slow. But if I start here on the y-axis at -3 for my first point, follow my slope up 1, right 1, or down 1, left 1, going through using a solid line as our inequality sign requested, and then also, according to the inequality sign, shading everything above it. Now, students at first think, I shaded everywhere. Well, yes, but we're most interested in where we shaded twice. And what, again, this is why I don't know why, but it's right here that I really love this graph. The shaded area that we shaded twice is everything between these two lines, which is neat because these two lines will never get closer. They'll never get further away. So if you were to look at this on a bigger graph, it's like a strip of shaded area that goes on forever and ever and ever, and it's perfectly the same width the entire time. So if I clean up the extra shading, that's what we're left with. So although the process feels very repetitive, these graphs, let me zoom out even more here. These graphs all could look pretty unique. Now, sometimes the region may be giant and take up most of your graph when you're all said and done. Sometimes it might be an itty bitty space. And it all just depends on where the signs take you, where you end up shading for both of your inequalities. Yeah. So that concludes systems of inequalities. Like I said, there's more applications involved if you want to get into something more advanced. But for right now, it's kind of a nice little way to wrap up our school week here with a little bit of light graphing and shading. Because like I said, I personally find it therapeutic. So at the very least, hopefully it doesn't feel like torture for each of you.